Okay, so this is the nomenclature 4 chapter. So with that, so from here we're going to be naming molecules that have different functional groups within them, right? So with that, so particularly things that have oxygens in them, oxygens, nitrogens, things like that. So we're not going to go through all of the ones in the chapters. So with that, so I didn't want to take the time to do them all. So with that, but these are some of the more important ones. So with that, so the first one up is the carboxylic acids, right? So these are going to have, all right. So this functional group here, right? C double bond O with an OH coming off of it. So with that, the nice thing is, right, it's going to be at the end of the chain, and so that helps us with the naming. Okay, so you're going to find and name the longest carbon stretch, okay, that contains the carboxylic acid group. Okay, so with that, so you need to find a longer one. If it doesn't have that carboxylic acid in it doesn't matter. Okay, but after you find that, you take the base name, right? So you replace the E at the end and add the suffix oic acid. So if there's 5 carbons long, right, it would be pentane, and then you would convert that into pentanoic acid. Okay, you name the side chains, right? So you find them, name them, okay, and then you figure out the numbering, right? Which carbon are they named? Now the nice thing is the carboxylic acid groups at the end is carbon 1, so you can go from there. So it's going to be at the end. That's going to be carbon 1. Okay, then you put it, and then you assemble it as normal. Okay, so you're going to put those the side chains up first. So by that you're going to put them in alphabetical order. Stuff like that. So, and if you have multiple ones where you have a di or a tri or a tetra or whatever, that doesn't count. Okay, but if you have, say, iso, like you have an isopropyl group, that does count. Stuff like that. So, so do be wary. So with that. So, and then the numbers are going to be out front of each of the side chain groups, right? So with that, and then your main chain at the end. Okay, so with that. So here you go. So you've got. So we got this one. Right, so you can always put in their dots for your carbons. Okay, so we have our carboxylic acid group here, right? So we're going to count, right? 1, 2, 3, 4, 5, 6, 7, right? Or don't forget to go down the side chains, right? 1, 2, 3, 4, 5. Okay, so our main chain is going to be here, right? It's 7 carbons long, which would normally be heptane, right? So with that, but you take off the E and add oic acid, so it'd be heptanoic acid. Okay, so now you're going to find those side chains, right? So you have a chlorine here, so it becomes chloro. Okay, and a methyl, right? So a methyl group here, right? Now don't forget these 7 carbons are already named within the side within the main chain. So we're just talking about the ones that are off the main chain. So we only have a 1 carbon piece off that main chain, so it's methyl. Okay, that's how the nice thing is, right? So the numbering automatically starts at the carboxylic acid group. So 1, 2, 3, 4, 5, 6, 7. Okay, so with that, so chloro's at 5, right? The methyl's at 4. Okay, so with that, so chloro becomes 4-methyl, so it becomes 5-chloro, 4-methyl, and then you put the main chain at the end, heptanoic acid. So there you go. Okay, now with alcohols. Okay, so with that, again, you're going to find that main chain is going to need to have the alcohol in here. Remember, so it's just going to have just a regular OH. Okay, so it's just like regular carbons on either side of it. Okay, so now here, the chain that has the alcohol group in it. Okay, but here you're going to take that base name and again take off the E, and here you're going to do OL. Okay, it's like for alcohol. Okay, so with that, so for here you're going to need to find those side chains. Okay, now the numbering begins on the end closest to the alcohol. Okay, but you're going to need to know. You are going to need to tell me where that alcohol group resides. Okay, is it on the carbon 1 or carbon 2, carbon 3, wherever? That's going to make a difference. Okay. So like that. So and then put the side chain in order and put the parent name at the end. Now you are going to need a number again where the alcohol is, where the OL is. Okay, so you can either put it out front of the main chain or within it. Okay, so like that. So for here, so for example, okay, again you can put in your carbon groups or your dots for your carbons. Right, so like that. So we're going to go right 1, 2, 3, 4, 5. Okay, but we could also do 1, 2, 3, 4, 5, 6. Okay, so this is actually going to be our main chain here. Okay, so 6 carbons, it becomes hexane. Right, you're going to take off the E and add the OL for the alcohol. So we have a hexanol. Okay, and stuff like that. So now find the side chains. Okay, so we're going to say that we need to number where that alcohol is. Okay, but we also have a methyl group here. Okay, I usually put these things in parentheses to reminder I don't need to actually write alcohol. That's what this OL is for. Okay, so with that, so the methyl, right? So this end is the side closest to the alcohol. So the numbering is going to start here. So it's going to be 1, 2, 3, 4, 5, 6. Okay, so the alcohol is hanging off of carbon 3. The methyl group is coming off of carbon 4. So when you assemble a name, it's going to be 4-methyl hexan 3-ol. Okay, so what it's saying is the alcohol is hanging out at carbon 3. Okay, now the older way that you could do this is say 4-methyl 3-hexanol. Okay, again, it's saying that the alcohol is hanging out at carbon 3, just like the methyl's hanging out at carbon 4. You could do it either way. This is the newer version. This is the old, but the old people know what's going on with the older version. Okay. I don't care which one you do. So, now for aldehydes, okay. So, but that. So again, right. So here, they're similar to carboxylic acids, but instead of an OH, it's just an H at the end. Okay, but here again, you need to find the chain that has that that functional group here, but here it's the suffix that you use at the end. If you take off the E, it's al. Okay, so that's for al for aldehyde. Okay, they need to distinguish it from alcohol. That's why it's not all. Alcohol's an all, right? But this one's an al. Okay, so again, find the side chains. Again, just like the carboxylic acid, that aldehyde is going to be at carbon 1. Okay, so we don't need to necessarily number it. Although if you do, I'm not going to care. Stuff like that. So put the side chains in there and put the parent name at the end, just like normal. Okay. So here we go. So we got this one. Again, you can put in your dots for your carbons if you want. That's fine. Okay, so here we go. So we're going to start here because it needs to start with that aldehyde. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so it's not really going to matter if we either go up here or go down here. It doesn't matter. So it's going to actually end up with the same name. Okay, but it's 6 carbons long, so it's hexane. We drop the E at Al for aldehyde. Okay, so it's going to be a hexanal. Okay, so our side chains are going to be these 2 methyl groups here. So with that, so methyl. So the numbering is going to start at the aldehyde. So 1, 2, 3, 4, 5, 6. Right. So we have a methyl group hanging off of 4 and a methyl group hanging off of 5. Okay. So it ends up being 4,5-dimethyl hexanal. Now, if you wrote 4,5-dimethyl 1-hexanal, not going to care. Stuff like that. So, but this is probably the better name. Stuff like that. So, but you're going to know what you're going to do. So you're good. So. Okay, so ketones. Okay, so ketones are right. So for here, okay, they're actually gonna be named similarly to alcohols. Okay, so with that in that right, so it's gonna be internal. Okay, so you got a C double bond O in the middle of it. Okay, so for here, right, so you have the it's gonna have name parent chain with the ketone group. Okay, so here the E is replaced with O and E, right? So that's for a ketone. Most people have a ketone in their medicine cabinet or in their bathroom, whatever, for acetone, right? The O and E indicate it's a ketone. Okay, it's a 3-carbon ketone. So with that, so actually this is this is actually acetone. Okay, it has a ketone in it. So with that, so that's where it gets its name, the O and E for that. Okay, so find the replace the name chain. Now, just like the alcohol group, okay, you're going to need to let me know where that ketone group resides. Okay, so with that, so you need to get the numbering for that ketone. Okay, but the side closest, the end closest to the ketone is going to be carbon 1. Okay, so with that, so when you put it just normal, but again, you're going to need to give me the position number of that ketone. Is it a 2 octanone? Is it a 3 octanone? Is it a 4 octanone? I'm gonna need to know that. So, okay. So here we go. Ooh. Okay. So again, you're gonna put your carbons and put your dots in if you want. Don't forget there's a carbon there. Okay, so here we go. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, well, it looks like it's going to be 8. So I'm going to take the middle ones just because stuff like that. So it's 8 carbons, right? So it's an octane, right? We're going to take off the E and add octanone. So we have an O and E, so it becomes octanone. Okay, so now we've got 4 methyl groups, right? This one, and this one. Okay, these are basically four separate CH3 groups. They act independently. This one here is part of this CH3. I said, okay, that one's part of the main chain, but we still have these two we have to contend with. Okay, so methyl, 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 methyl. And then you have to do the ketone, right? You have to let me know where that is. Is it here, is it here, is it here? So with that, so you have to let me know. Okay? So here, right, so this is the side closest, to that ketone, so we're going to start the numbering here. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so with that, so the ketone's hanging out at carbon 3. We have a methyl at 2, a methyl at 6, and then we have 2 independent methyl groups at 7. Okay, so with that, so when you assemble the name, it becomes 2,6,6 tetramethyl. Okay, I've got a tetra here. I need 4 numbers there, right? Because if you were to write 2,6,7 tetramethyl, I would have no idea where that other methyl group was. Okay, so you got a tetra. I need 4 numbers here, even if they're the same number. Okay, so with that, so I have 4 methyl groups here. You can do octan 3-one, right? So where's the ketone? It's at carbon 3. Now the other way that you could write this would be 2,6,7,7 tetramethyl 3-octanone. That's the older way of doing it. That's perfectly fine. Stuff like that. So okay, so it's just saying that the octanone or the ketone is hanging out at carbon 3. So there you go. Now cyclic ketones come up quite a bit, okay, but we're going to do it just so, we're going to do the same rules, okay. But the problem is, right, where do we start carbon 1? Well, nice thing is what we do is we say, okay, carbon 1 is going to be where that ketone is, right? So here we go. When I put in our dots for our carbons, right? Okay, so you're either part of the ring or you're part of the main chain. You can't be both, right? So I can't go like this around. Okay, so it's either going to be this 2 carbon piece, that 1 carbon piece, or this 5 carbon ring here. Okay, so you're either part of the ring or you're part of a straight chain. Okay, so the main chain, right, would be cyclopentane, right? It's 5 around, so it's 5 carbons, right? So it's a pentane, but we have to indicate that it's a ring, so we put cyclo out front. Okay, but again, we're going to take off that E and add the O and E, just like normal, right? So it becomes a cyclopentanone. Okay, now the okay, so we're going to have the methyl, the ethyl, and you could write the ketone. It's not a bad idea when you're starting out to go ahead and put that in there just to get in the habit. And cyclic ketones is not as big of a deal, but go ahead and do it while you're starting out. Okay, so the nice thing is you're saying, okay, so I can do, so this is definitely going to be 1. So I can either go clockwise, 1, 2, 3, 4, 5, right? So this would be, so if I had methyl, ethyl, right? So with the black numbers, right, it becomes 2, 3. If instead I started here at 1 and went counterclockwise, 2, 3, 4, 5, right? So with that, so here it'd be what, 4, 5, right? So you add them up, so it's 5 versus 9. You get to figure out which is lower, and so you end up with this numbering here. Okay, so the 3 and the 2. Okay, so ethyl is going to be out front. So like that, because it's ethyl comes before methyl, so it's going to be 3 ethyl, 2 methyl, cyclopenta 1-one. Okay, now the other, again, you could write it 3 ethyl, 2 methyl, 1 cyclopentanone. Now, if you just have 1 ketone, you could get away with not putting the 1 here because it's understood. So with that, but it's never a bad idea when you're starting to just go ahead and do it until you get better at it. So just get in the habit of putting it in, so you don't forget to do it when you're doing a straight chain. Okay. Now, there are times when, and we'll talk about this more at the end of the chapter. There are times when there's, say, a mixture of alcohol. An aldehyde and a ketone. It turns out the aldehyde gets the priority, so we're going to number it as if it were an aldehyde. Okay, so how do we deal with this ketone group? Well, we name it just as a side chain. Okay, so this carbon here, that's part of that side chain. Okay, so really, all we need to do is name the oxygen, right? So if we had a chlorine, right? right? So if we had a chlorine, right, it goes chlorine to chloro, right? Right. If we had a bromine, right, it goes to what? It goes to bromo. If we had a fluorine, right, where does it go? It goes to fluoro. Okay. Right. So but that's it, right. So this was what, chlorine. What do we do? Right. We took off the I and E and added an O. Bromine, we took off the I and E and added an O. Right. So what are we going to do? Oxygen, right? An oxygen, right? What are we going to do? We take off the suffix and just put an O there, so it becomes oxo. Okay, that's how they came up with this thing. Okay, so I'm going to put in the carbon groups here, right? Okay, so here we go, right? So we have 1, 2, 3, 4, 5, 6, right? 1, 2, 3, 4, 5. Now you could do 1, 2, 3, 4, 5, 6, 7. But it doesn't have the aldehyde group in here, so you're stuck doing the longest chain that has the aldehyde. Okay, so so what do we have? We're here. So 1, 2, 3, 4, 5, 6, right? So C6, it becomes hexane. So you take off the E, so it becomes hexanal. Okay, and then we have the side chains, right? So we have the oxo here, okay, and we have the ethyl here. Okay, but nice thing is, right? So we know where carbon 1 is. So that's 1, 2, 3, 4, 5, 6, right? So the oxo's hanging out at 3. And the ethyl's at 2. Okay, so it ends up being, right, so ethyl comes first, right, because it comes first alphabetically, so 2 ethyl, 3 oxo, hexanal. Okay, you could also say 1 hexanal, that's fine. So with that, so 2 ethyl, 3 oxo, hexanal, right? Ethyl comes before oxo, so you put the ethyl first. So there you go. So here you go. That's it. Okay, so amides aren't too bad. Okay, so with that, so here you've got right, you're going to have some sort of nitrogen on here. Now you're going to have some sort of maybe like a carbon group here and maybe a hydrogen. You may have 2 hydrogens, you may have 2 carbon groups. It doesn't matter. We're going to name we don't have to name the hydrogens because those are assumed to be there. But we are going to have to name any other group that's hanging off of here. Okay, but again, what you're going to do is this carbon here, the C double bond O, that is going to be the that's going to be carbon 1, and it's the ones it's going to be the carbon chain going away from the C double bond O side. We'll get to the stuff over here in a minute. Okay, so like that. So it's the longest chain on the C double bond O side of that amide. Okay, so with that, and so this is actually makes sense, right? So you do that, you replace the E with amide. Okay, it's one of the first times it actually makes sense. Okay, now you're going to need to find the side chains that are over here, but then you're also going to label anything that's hanging off of that nitrogen as well. Okay, anything that's hanging off here. Now, except for the hydrogen, you don't have to worry about that. But the other groups that are hanging off the nitrogen, you got to let me know about that. Now, if it's on the C double bond O side, you just give it a regular number. Okay, and the numbering is going to start here. So if it's 4 away from this, or it's hanging off of carbon 4 over here, it's just going to get a number 4. If instead the group is hanging off of nitrogen, you give it an N. Okay, and now it's no different than any other number. Okay, so it just happens to be a letter, but we treat it just like any other number. Okay, now you assemble it as normal. Now include that position number of the N. Okay, so and then put the parent chain at the end. Okay, so not too bad. Okay, so here we go. So we got this molecule here. Okay, so I'm going to put in the dots for the carbons, right? Okay, so for the main chain, it's going to be on the C double bond O side. It's going to be going away from the C double bond O. So it goes, right, so it's going to go, right, 1, 2, 3, 4, 1, 2, 3, 4. Well, okay, so it's going to be 4 long. Okay, so butane, so it becomes butanamide. Or sometimes you see butamide. That's fine, too. So like that. So there we go. Okay, so now our side chains, right? So we have a methyl group here, we have an ethyl, and we have a propyl. Okay, now the methyl group is hanging out on the main chain side, so it gets a normal number, right? So we're going to go 1, 2, 3, 4, right? So it's hanging off of carbon 3. Now this ethyl group is hanging off the nitrogen, and so is this propyl, so they're each going to get an N. Okay, and so the way that we assemble this, right? Ethyl is going to come first, right? So it's N-ethyl, and then 3-methyl, and then N-propyl butanamide. Okay, now if you had a mix, so let's say this was a methyl. Okay, so you would say 3N-dimethyl. Okay, you would still combine it. Okay, but the N usually goes first. You do the numbers and then letters. So if it ended up being 3N diethyl, N propyl butanamide, stuff like that. So that's how you would end up those. But this makes somewhat sense. Okay, the N saying there. Okay. Now comes to esters. Now esters, this is a relic from how this is a really crazy numbering system or naming system, and it's a relic for how the fact that they made them before they knew what the heck was going on. Okay, and so remember, ester is very similar to amides. Okay, but instead they have an oxygen here, and so what you need to do is you need to look at the two parts. Okay, you're going to need to look at the C double bond O side, and you're going to need to look at just a regular oxygen side. Okay, now you're going to want to do the oxygen side first, and you're going to need to name this part here. Okay, but you're going to name it as a side chain. So if it's 3 carbons long, it would be 3 carbon long group is a propyl group. Okay, or an isopropyl group, or if it's 4 carbons long, it'd be butyl group. Whatever. Okay, but it's going to be named as a side chain. Okay, then you look on the C double bond O side. Okay, and then you name that side normally. Okay, but the main chain is going to be E. Instead of E, it's going to be O8, or sometimes it's 8, depending on how well it comes off the tongue. Now, the way that you assemble this is you bolt in, no matter what this is, no matter what the O side is, you put that first, even if it starts with a Z. Okay, you put it first, and you do not mix. You do not mix them. Okay, and then you bolt in the C double bond O side. So usually, what I'll do is I'll put parentheses around there just to remind myself that I do not mix them. Okay, it's going to be this side, this first, and then this, no matter how screwy the name looks. Okay, stuff like that. So so here we go. So we got this simple one here. Okay, so we have put in our carbons, right? So here. There and there. Okay, so we're going to cut this in half, right? So, so this side here, okay, so it's 2 carbons long, right? So it's ethyl, okay, so it's, ethane, it should be ethane, right? So so it becomes ethyl, okay, so ethyl, okay, so, and if it was like this, okay, I'm gonna be a little crazy, and I'm going to put a chlorine here, okay? Okay, so this ends up being butanoate, okay, but it ends up being 3-chloro. So for this new molecule, it's going to be 3-chlorobutanoate. Okay, so that's this side here. Okay, now the way you assemble it is the O side and then the C double bond O side. So it ends up being ethyl 3-chlorobutanoate. Okay, you do not mix in. You say, well, hey, the ethyl should be in here. No. You do not mix them. Okay, that's why I put the parentheses there. You don't. Most places don't. Most people don't put the parentheses in there. I do when you're starting out, just to remind yourself. Okay, this part here comes out first, no matter what it is, and it is not mixed in. Okay, I can't emphasize that enough. It's a really screwy naming system, because what they ended up doing is they took a carboxylic acid and they mixed it with an alcohol, and so it would be like the ethanol version of I mixed ethanol with the acid. Okay, so it'd be like ethyl is the ethyl alcohol of butanoic acid. Okay, so that's sort of a very sort of 19th century name. Okay, and then they never got around to fixing it, stuff like that. So you're having to deal with that. So okay, now what happens if there's multiple functional groups? Right, it's going to happen. Okay, now so with that, so you are going to have to let me know, and you're going to have to use that di, tri, tetra, penta, whatever. Okay, stuff like that. So for here, you got heptane 1,7-dioic acid. Okay, you could stuff like that. So it's preferred not to put this out front of here, because you want to make sure that you don't have 2 of the heptanes. You could do it, okay, but it's not a big deal. But I need to see the di here. Okay, yeah, okay, I take that back. You could do this 1,7 heptane dioic acid. Dioic acid. Okay. Now the di has to go in front of the oic acid. Okay, because you're saying I have 2 of these. Okay, I have 2. Or I should say 2 of these. Okay, if you do 1,7-diheptaneoic acid, they're going to think you have 2 heptanes, stuff like that. So no, you don't have 2 heptanes, you have 2 oic acids. Okay, now for here you could get away with only doing 1, and you could probably get away without the numbering on this particular one because that's the only place they could be, stuff like that. But it's when you're starting out, it's good to put the names in. Okay, now for here, right, it's 2, 2, 3. I have, right, so if I did this 1, 2, 3, 4, 5, 6, 7, 8, right, so with that, so I have 5 alcohol groups, right, 1, 2, 3, 4, 5. Okay, so right, so 5 is penta, right? It's not pentane, it's just penta. Okay, I have 5 of these. Okay, 1, 2, 3, 4, 5. Okay, so octane out here. Okay, so main chain is 8 long. I have 5 alcohols. Where are they? At 2, at 2, at 3, at 4, at 5. Okay, so with that, again, if I were to write 2, 3, 4, 5 pentaol, I would have no idea where that 5th one was. Okay, so if I have a penta here, I need 5 numbers. Okay, and typically if a di, I need 2 numbers, even if they're the same number. Okay, so with that, so. Okay. So now the last thing to do is to say now there are priorities, right? So we already talked about one, that the aldehydes have a higher priority than ketones. Okay. Now the way this works is carboxylic acids have the highest, then anhydrides, esters, acid chlorides, amides, nitrins, and what ends up, they're looking at one of these, the one side of the group, right? The carbon, one of these carbons here. Like that. So these guys here, when in doubt, you can look at the number of carbon heterocycles or carbon heteroatoms. Okay, so carbons bonded to non-carbons and hydrogens, right? So this one has, right, 1, 2, 3, right? This one has 1, 2, 3, but you're saying, wait a minute, but it also has these. Well, we're just looking off of 1 carbon, stuff like that. So this one, again, 3, right? This two carbon oxygens and a carbon chlorine, 2 carbon oxygens and a carbon nitrogen. Okay, so for that, so these are going to be a higher priority than say aldehydes or the ketones, because these only have 2, right? So 2 carbon oxygen bonds, 2 carbon oxygen bonds. Okay, and then down by here, the alcohol and the amide, right? These only have 1. So that's a kind of a good rule of thumb. Carboxylic acid gets the highest. Okay, aldehydes, stuff like that. So for my class, you're only going to need to know the carboxylic acids, esters, amides, aldehydes, ketones, and alcohols. Okay, the other ones we didn't name. Stuff like that, you could, stuff like that. So again, now one of the things to notice is that, right, so we talked about the oxos, so aldehydes and ketones, right? So if it was a carboxylic acid and an aldehyde, you'd name that aldehyde like an oxo, just like you would name it for a ketone. Now the other one, and this comes up a lot with the alcohol, since it's such a low priority, it's almost always going to be listed as a side chain. For there, it's going to be it's called a hydroxy. Okay, amides are another one where it's an amino, stuff like that. So if let's say you have a nitrile and an amine, the nitrile is going to get the higher priority. The amine, and this would be named as an amine. So these are 2 that these are ones you're definitely going to need to know: the oxo, hydroxy. My class, you're going to need to know amino, but you should probably know that for down the road, stuff like that. So okay, good luck.